work. Okay. So Al, let's take a look at number 9. Number 9 said, I have 2 times a quantity of 7 minus g is equal to 9g plus 14 minus 11g. Is this the one you're talking about? Awesome. All right, so Al, the first thing I need to do is I need to simplify both sides. On the left side, simplifying it means that I do the distributive property. So 2 times 7 is 14 minus 2 times g equals, Al, I'm going to do the, adding the opposite on that right side so I can move my like terms together. So I have a negative 11g plus 9g plus 14. So I have 14 plus a negative 2g is equal to negative 2g plus 14. I do want you continuing to finish, but all of you, hopefully by looking at this, can see that the left side does equal the right side, so this will be identity or infinite solutions, but I want to finish because I don't want to make any assumptions, because if I looked at this wrong, I'm going to state the wrong thing. All right, so I got 14 equals 14, so this means identity or infinite solutions. Yeah. I want you finishing, because there's going to be a time that somebody doesn't see this negative here, or they're not going to see that this is a minus, which means this is a negative, and they're going to look at it and they're going to be like, oh, this is no solution. So I just want you to be diligent. If you're on the high school placement test, I don't care. But for me now, I want you being diligent, so it just keeps you paying attention right now. What else can I do for you guys? Okie dokie, let's get our notes out. Okay. Today is October 16th. All right, we are in Chapter 2, Section 6. All right, there's 2.7 is the last one, and then that's the end of the chapter. So we are getting close. All right, for the next 2 chapters, we are going to be working with proportion ratios and proportions. All right, so 2.6 is right, ratios, and proportions. So let's remember what those are. All right, so a ratio, this is when we are comparing 2 quantities that have the same unit. Well, technically they have the same units. Although I overuse the word ratio. All right, but it's comparing 2 quantities that have the same units using division. That's a fancy way of saying a fraction. So basically it's a fraction. All right, it's a fraction in math. If we were to describe it, we could say something like the ratio of boys to girls is 3 to 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 to 11. So we're comparing boys, the amount of boys to the amount of girls. All right, so one way that we can write the ratio is how you have it seen here. Another way that you can write this is 3:11. This should be a review for you guys. And in math, it's 3 over 11. That's how we use it in math, is as a fraction. The numerator is always before the 2 or the colon. The denominator is always after the 2 or the colon. All right, so I want you to write some ratios for me. All right, so maybe you guys play volleyball in here. Connor, you do. Do you play outdoor?
No, they're doing, they said Michigan in the league.
Nice.
Are
Are they starting one?
They're trying.
They are. I wish they would. You know, a long time ago, the high schools had boys club teams. I loved it. I would love to see guys play more volleyball and have teams for it. Your mom was big volleyball.
Yeah.
Yeah. What'd you say? I know they are, which is why the guys have a taller net, but unfortunately sometimes it doesn't even help because they sky over the net. I know. I played in a co-ed league in outdoor with my husband when I was dating him, and then in the Detroit Social Club I played in the men's league. They have the higher nets. Clearly, I'm a setter, so clearly I just was the setter or back row. Like trying to hit was ridiculous. It's just you're just doing a down ball, like it was dumb. But I love volleyball. I do. I love volleyball. So anyway, okay. So the volleyball team plays 14 home matches.
Teachers and students, please pardon the interruption. We have Jacob Cassatt to do our afternoon prayer.
Father, Son, Holy Spirit, amen. Dear God, thank you for everything you've given me and what's able to take back to school. Also to be able to go to church every weekend and pray. Another thing I'm blessed for is to have a roof over my head and food on the table every day. And thank you. And thank you, God, for having good health to play sports. Thank you, God. Amen. Just give me more gratefulness.
Father, Son, Holy Spirit, amen.
Great job, Jacob. I'd like to wish several happy birthdays today. Happy birthday to Clara and Helena Abreu. Happy birthday today, Clara and Helena. And another set of twins, Connor and Henry Hamill. Connor and Henry, happy birthday today. In the preschool, we have Brooke and Sophie Janeway. Happy birthday, Brooke and Sophie. And then Xander Sabat in the first grade. Happy birthday to Xander. So amazingly, we have 3 twin birthdays today. Happy birthday once again to Clara and Helena in the preschool, Brooke and Sophie in the preschool, Connor and Henry in the 5th grade, and Xander in the 1st grade. I hope you all have a wonderful birthday today. Congratulations last night to our volleyball team, as the 5th, 6th grade girls volleyball team beat the St. Joseph Mavericks. Congratulations, as it was their last game of the season. Way to finish on a high note to our 5th, 6th volleyball team. Way to go. Again, keep in your prayers Joseph Jolak, who had surgery on his elbow today, and William Richland as he recovers very nicely from having his tonsils out. Addison Smith, make sure you have everything packed up and ready to go, and please head down to the office now. Those are your announcements for this Wednesday. Have a wonderful rest of your Wednesday. Thank you.
Okie dokie. Somebody write my ratio for that first part. Carmen?
14 times 14 over 10 or 14 over 10.
Okay, so I'm gonna write as 14 over 10, and then can you simplify that for me?
7 fifths.
7 fifths. Leave it as an improper fraction. So I'm going to say leave as improper fraction because it is a ratio that we are writing. Somebody do the second one for me. Al?
14 out of
Excellent. And then simplify that.
7
Yeah, that's right? Yep, 7 out of 12. I know, you made me rethink it. I mean, you guys are cool with proportion, or with ratios. Okay, let's talk about proportions. I'm just going to start with the story problem, and we're going to remember how to solve them once we've written them. Okay? So when we talk about proportions, proportions are a known ratio or fraction set equal to our unknown ratio or fraction. When we talk about our unknown, one piece is missing. So I want to show you a story problem. God bless you. I want to show you a story problem. All right, so when we talk about proportions, what we do is we create proportions, we create ratios. Now let me take a step back. Let's talk about when we want to use this. We use proportions when we are comparing two sets of data. So we're comparing two sets of data. All right. We have a known relationship between the data that we use to find part of an unknown relationship of the same data. All right, so this is one way. Obviously, we have scales, we have similar figures. Remember, we'll do more of those. But from a story problem standpoint, if we are comparing the amount of money you make and the amount of hours, right? And then we know that relationship. 5 hours, you make $85. But then we're like, okay, for 9 hours, how much money are you gonna make? That's the relation. We have a known relationship between hours and money, and an unknown relationship between hours and money. All right, so we're comparing two sets of data. We know one full relationship and part of another. That's what we're looking at here. That's what this means. All right, so let me show you an example. This is in your book. Who needs to see what's up there? Okay. Again, we did this last year, but proportions is something that's super. This isn't going to help.